Hi, this video is on chapter 4, section 9, addition and subtraction equations. Good news about this lesson is that you have all the skills to do well with what we're going to talk about today, because you know how to add and subtract integers and rational numbers, and you know the properties of equality. So you're going to put these two things together to solve equations. But one of the big ideas here is that you can add or subtract the same amount to or from the left and right sides of an equation, and the equation is still true. So if you have an equation that says x plus 3 equals negative 4, you can undo adding 3. Remember how we can cover up the variable and do the opposite of what you see there. So instead of add 3, subtract 3. And this is a 0 pair, and x plus 0 is x. You can do the change, and get negative 7. So that would be a solution. The negative 7 plus 3 would be negative 4, turns out to be true. So that's the properties of equality. There's an addition property of equality, which says you can add the same thing to both sides of an equation, and a subtraction property of equality that says you can subtract the same thing from both sides of an equation. So the basic strategy is going to be to solve the equations that you'll have on page 97, simplify both sides. If they're not already simplified, then simplify them, do all of the addition, subtraction, multiplication, division that you can do. Then you apply either the addition or subtraction property of equality. Because everything in this lesson will be add and subtract. When we do 410, it'll be focusing on multiplication and division. So let's take a look at a couple examples. The first example is from page 96, and I'm going to do that example in a slightly different way. But I would encourage you to look at page 96 and see how the authors of your textbook solved. They used the same ideas, but they worked with the fractions a little bit differently than I want to suggest you might do. So we see we've got everything is simplified, because you can't do any more here. You can't subtract things that are different, and there's no arithmetic to be done over here. So what we're going to do is the opposite of subtracting 1 3/5. So we're going to add 1 3/5. And whatever we do to the left side, we have to do to the right side. And the 3 steps that you have to go through and show are copy the equation, undo something using a property of equality, and then do the arithmetic. And it's the doing the arithmetic part that the authors of your book do slightly different, because they change this to a mixed number and make it 5 times 1 plus 3, 8/5, and they make this 3 times 2 plus 2, 8/3, and they work with the improper fractions. But you can do that, or you can do it this way. And then maybe off to the side you would say, I'm combining a negative and a positive number. So you have to find the difference between the absolute values of both of these, and think about whether the answer will be positive or negative. If it were negative 2 plus 1, just ignore the fractional parts, you'd say I've got more negatives. If I have 2 negatives and 1 positive, I had 1 more negative than positives, so it would be negative 1. And that's a good way to estimate. This answer should be close to negative 1. But I'm going to do 2 2/3 minus 1 3/5, because I have to find the difference between these two absolute values. My common denominator is 15. And when you set it up this way, it's important that you put the whole number part. Don't just say 2 2/3 equals, I'm going to multiply by 5. Don't say 2 2/3 equals 10/15, because it doesn't. 2 2/3 equals 2 10/15. And what do I multiply 5 by to get 15? The answer is 3. So this would be 9/15. And remember, I want to find the difference between the absolute values of these two numbers. So the difference between their absolute values is 1 1/15. But it must be a negative 1 1/15, because there's more negatives than positives. And we had estimated that the answer would be about negative 1, and this is pretty close to negative 1. So again, this is an example of a problem that's shown on page 96 in your book. Then I'm going to do problem number 13 from page 97, and the solution, of course, to that is not shown in your book, but it's a more complicated problem, and you first look at it, you might say, no way. But like a lot of problems you have, if you break it down, it's not too difficult. So this side looks pretty basic. It's 4 plus a number on the left side, but this looks a little more complicated, and this is not simplified, so this is where our directions to simplify both sides comes in. We have 7, and then added to that is the product of 1/2 and 2/3. Multiplication has the priority over addition, so we do this first. And we notice there's a 2 here and a 2 here, so we can reduce before we multiply. And the right side becomes 7 plus 1 times 1 over 1 times 3, which is 7 1/3. Everything's staying the same over here for now. And this looks much more easy to work with than what we had up here. So we see we're adding to m. What are we adding? 4. So we do the opposite of that and subtract 4. 0 pair. M equals 7 1/3. It's not a bad idea to put 0/3 here. You wouldn't have to do that, but it might keep you from making a mistake in a more complex problem. 1/3 minus 0/3 is 1/3, and 7, I'm not doing very well keeping that lined up for me. 1/3 minus 0/3 is 1/3, and 7 minus 4 gives you 3. And so 3 1/3, and we want to come here and ask, so likely this is 3 1/3. 4 plus 3 is 7, 7 1/3 equals 7 plus, this is, I hadn't thought about this before, but what's half of 2/3? Didn't really need to go through all this stuff. Half of 2/3 is 1/3. So you probably could have worked through this pretty quickly mentally. 7 plus 1/3 is 7 1/3. Yeah, the answer checks out. So that's your last step. Put the value that you have for the variable back into the original equation and make sure that it's reasonable. So that's, if you've done a good job on the sections up to now, section 4.9 and 4.10 are pretty simple because there's not anything really new in that. It's just putting a couple skills together.